Assalamualaikum warahmatullahi wabarakatuh, and a very good morning I wish to our lecturer control system, Encik Muhammad ZAIDI bin TUMARI. My name is NORSABRINA binti AZLAN, and I will be the first presenter from Group 5, which will be presenting our assignment control system, which our chosen product is an automatic toaster. Our group members consist of 4 people, including me. First and foremost, let me introduce to you a little bit about the application of an automatic toaster. So, an automatic toaster with the feedback is taken as an example of the practical closed-loop control system. The input of the system is the desired quality of the toast, while the output is the actual quality of the toast. The actual toast quality in the toaster is measured by a quality measuring device like a color detector placed in the toaster. It produces a signal proportional to the toast quality, which then compared with the desired toast quality to generate an error signal. This error signal is detected by the controller that changes the heating time. And from there, the heating time is changed through relays such that the error is reduced. So, what happens inside a toaster? Let me explain to you. Based on the figure in the slide is a little representation on step-by-step what happens to a bread in a toast. So firstly, electrical energy flows into the toaster from a wire plugged into a domestic electricity supply. Second, the electric current flows through a series of thin filaments connected but spacely wide enough apart to toast the whole bread's surface. Next, the filaments are so thin that they glow red hot when the electricity flows right through them. Fourth, like a series of small radiators, the filament beams heat towards the surface of the bread in the toaster. The steady supply of heat rapidly cooks the bread on both sides. There are filaments on each wall of the toaster so that both sides of the bread cook evenly at the same time. In this slide, I will be explaining about the block diagram. So as you can see from the figure in the slide, this is a little representation block diagram of a toaster. So as you can see, the input will be the desired toast quality. Next, it will be transferred to the comparator. From there, it will be transferred into the controller, which is the relay to control heating time. Then the data from the system will be inputted into the system, which is a toaster. So since this is a closed loop control system, there will be a feedback path to the system, which is the toast quality measuring device. So if there's any error in the system, the loop will replay itself until we get the desired output, which is the actual toast quality.
Hi, Assalamualaikum. My name is Nurain FIRZANA. I will be present about the system transfer functions. Based on the block diagram from previous slide, we have to convert it to the signal flow part so that we understand it better, and then we have to model the system's transfer functions. Here is the block diagram of control system of automatic toaster. The diagram below is the signal flow graph that obtained from the block diagram. So, from the block diagram, Ys is equal to G2 times G1 open bracket Rs minus Hs times Ys close bracket. So, from here, we get the transfer functions, which is Ys over Rs equal to G2s times G1s over 1 plus G2s times G1s times Hs. So, we assume the value for the system transfer functions is Ys over Rs equal to 2 over 2s power of 2 plus 4s plus 20. Hi, I am Nurain and I will explain on how to get the system response, the graph of system response from the MATLAB online. Get the MATLAB online and then enter the MATLAB command, which is hash equal to tf transfer function open bracket and a square bracket. Enter the numerator value, which is 2, close square bracket, comma, open square bracket. Insert the denominator of the value, which is 2, 4, 20, and a square bracket, close bracket, and semicolon. Then you click enter. The next is you need to type the step lot, and you need to mention back with the hash and enter. From here, you can get the graph. So, from this graph, you can right click, and for the characteristic, you can, for the peak response, settling time, rise time, and the steady state with. The next step is by type the step info, and you need to recall the first one, which is hash, and enter. And from here, you will get the result. By using the MATLAB software applications, the system response for the automatic toaster system can be obtained from this graph by using the MATLAB command. And here is the result, which is the rise time is obtained 0.4259, the settling time is 3.5359, and the overshoot percentage is about 35.0670, and the peak is 0.1351, and the peak time is 1.0592. Hi, I am Nurain and I will explain the calculation for this project. We assume the equation is 2 over 2s power of 2 plus 4s plus 20. First, we need to find the natural frequency, which is Wn power of 2 equal to 20. Wn is equal to 4.4721. Next, we need to find the damping ratio to zeta Wn equal to 4. The zeta is equal to 4 over 2 times 4.4721. The value of 4.4721 is obtained from the natural frequency, and the final result for the zeta is 0.4472. Next, we need to calculate the peak time, Tp. So, pi over Wn square root 1 minus zeta power of 2. So, the final result will be 0.7854 seconds. For the settling time, Ts will be the 4 over zeta Wn. And the final result for the settling time is 2s. So here is the calculation for the rise time Tr is pi minus tangent negative 1 square root 1 minus zeta power of 2 divide zeta and divided Wn square root 1 minus zeta power of 2. The final result is 0.7767 seconds. Next, for the percentage of the overshoot, the exponent negative, open bracket, zeta pi over square root 1 minus zeta power of 2, close bracket, times 100. By substitute the zeta value, so we will get the value for the percentage overshoot, which is 20.79%. From the data that we obtained for the peak time, the settling time, and the percent overshoot, there is a comparison between the calculation value and the graph value, whereas the percent of overshoots for the graph value is 35.07%, which is higher than the calculation value, 20.79%.
Hi, my name is SIVANESWARAN like MANOKARAN. I'm from BMMP2343. Today I want to present how to system transfer function to state space representation. Okay, I want to show the calculation step by step. Okay, firstly CS over RS equal to 2 over 2s squared plus 4s plus 20, and then 2s squared plus 4s plus 20 equal to CS equal to 2RS. Okay, after that equates the formula 2d squared c over dt plus 4dc dt plus 20c equal to 2r. Okay, define x. Okay, we must define the x, x1, x2, s3, and then c1, c dot, c double dot. Okay, after that define input variable u equal to r1. Okay, differentiate the state variable. Okay, x1 equal to c dot equal to x2. Okay, x2 equal to c2 dot equal to 2u 2x3 minus 4x squared minus 20x, and then state the equation in the metric form. Okay, after we have the metric form, we can get the output equation equal to yx equal to cx equal to x1 equal to yc is 100 times x1 x2 s3. That's all. Okay, I want to explain the stability of the system. The stability of the system can calculate using the Rod-Hurwitz table calculation. Okay, through the calculation we can know the system was stable since there was no sign change at the first column. After that, the Rod-Hurwitz declared that the number of roots of the polynomial that are in right half plane is equal to the number of signs change in this first column. Hence, there was very stable.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUHAMAD HAKIMI bin ABDUL HALIM. Now I will continue the presentation with the steady state error. There were three calculations for the steady state error, which is state input, array input, and parabolic input. There were the three diagram below is a calculation for the state input, parabolic input, and RAM input. For the state input, we will gain 0.091 value. Next, the RAM input we will get infinity value, and lastly the parabolic we will also gain the infinity value. So from the calculation we can determine that this is a system type 0. The reason that it's a system type 0 is because the RAM input and parabolic input were infinity value. For the discussion of the project, we know that the automated toaster is a closed loop system. A closed loop system control is a type of control system in which the controlling action shows dependency on the generated output of the system. In simple words, in this system, the output of the system control the input applied to the system. for the automatic toaster, we look the loop output is color of the bread. If the color doesn't match the needed color, the toaster will toast the bread until it gets the needed output. From the MATLAB simulation, the graph shows that it is an underdamped second order system where we can get the value of peak time, settling time and percentage overshoot to be compared with the calculation value. For the steady state error, we got 0.091 value for step input, while RAM and parabolic input were infinity. This is because the error system depends on two factors, which is the type of system and input.
Conclusion. In the end of our assignment, we conclude that automatic bread toaster was closed loop system, and then it was an unramped closed second order system. Okay, based on the block diagram also, we conclude the system outcome of the bread toaster was measured by the color of the bread, whereby the sensor will give a feedback when the toast finishing baking. From this assignment, we have learned much of the thing in control system. Thank you.